Hello, this is Dr. Mears, and today we're going to be learning about exponential equations. Let's first take a look at this note. The note says we need to change the same base, so let's look into this. I want to just go over what a base is. So if we have 3 to the third, the base is that bottom number, and then the little top number is the exponent. Now what this means is we're going to take the number 3 and multiply it times itself 3 times. So the exponent tells you how many times to multiply the base times itself. So this equals 27. This is actually going to help us do number 1. So number 1, 3 and 27. We need to change these so that they have the same base, the same bottom number. I gave you a hint here. Yes, I just kind of did it for you. So this is 3 to the first. We need to change 27 so that it has a base of 3. So what power can I raise this 3 to where I can get back to 27? And you just did see me do it here. 3 to the third power, 3 times 3 times 3 is 27. So now we have same base, 3 and 3. Exponents are different, that's fine because we are working with the numbers 3 and 27. So 3 to the first is 3 and 3 to the third is 27. Same base. Let's look at number 2. We have 4 and 8. So the first thing that you have to ask yourself is, can I change 8 so it has a base of 4? Well, I can't do that. 4 raised to the second power is 16. 4 raised to the first power is 4. 4 raised to the second is 16. So that's not going to work. Okay, that was like this one here where I did give you the base with the example. But we don't have the base here. So we have to think, what base can I use that I can change from 4 into 4 and into 8. And you're right, I think you're already thinking of it. It's going to be base 2. So what power do I have to raise 2 to to get to the number 4? And you're right, 2 squared is 4. So it's going to be 2 squared. Okay, what exponent do I have to raise this 2 to get to 8? So it is going to be, let's see, 2 times 2 times 2. 2 times 2 is 4, times 2 is 8. So you're right, it is going to be raised to the third power. So here we have same base, but different exponents. 2 squares gets you back to 4, and 2 cubed gets you back to 8. So that's what I mean by changing to the same base. We're going to be using this skill to help us solve. Now on to solving. Number 3, we have to solve 3 to the x plus 2 equals 27. So we have to find what number can I put in for x that gets me to 27. Now you might be able to see it from here, and that's absolutely fine if you're like, oh, I know what the answer is. But let's look at the technical aspect just in case the problems get a little bit harder. You know what skill to use to be able to solve, because sometimes we're not going to be able just to see the answer. So I think you're thinking that we're going to definitely have to change to the same base, and that's why I did that example here. So the 3 and the 27, in order to solve this, we have to change the same base. We can leave 3 to x plus 2. The base is going to be 3, you're right. And the 27 is going to change into 3 cubed. So instead of writing the number 27, I'm going to be writing 3 cubed because that is 27. Now that I have the same base, what I'm going to be able to do is cancel these out. And my equation is just going to be the exponents equaling each other. So it's going to be x plus 2 equals 3. And I just write that down because I really want to find what x is going to be. And since these are the same, I'll be able to find what x is by minusing 2 from both sides. X equals 1. So what does that look like if I check it? And you don't have to go through and check, but I want to show you what's happening here. So if we check, what I'm going to do is I'm going to substitute 1 in for x. So 3 plus 1 is 2. 3 to the 1 plus 2 should equal 27. Well, 1 plus 2 is 3. And I'm right. 3 squared, 3 cubed does equal 27. Yay! So we're finding what missing number. What's the missing number that makes this statement true? All right, let's try this one. You're right, 4 and 8. So we have 4 raised to the 2x plus 1 equals 8 raised to the x plus 2. And yes, you're saying we're going to be changing into a base of 2. So this 4 will get changed into 2 squared. But here's where you have to be careful, because what I have to do is I'm going to have to multiply the 2x plus 1 times the 2 that I changed my 4 into 2 squared. So you have to put parentheses around this. And if you want to put parentheses automatically right when you start the problem so that you don't forget, I would do that. The parentheses aren't going to be provided for you. And remember, this year, I'm parenthesis happy. I put parentheses around everything. Okay, and you're right, the 8 is going to get changed into 2 cubed. But I'm going to have to multiply my x plus 2 times that 3 because I have to cube my 2. So remember, put parentheses around this regardless of the problem. You could have even done it here, that's fine. Because when you do change your base, you are going to have to multiply. Since I have my same base, they cancel out, and my new equation is 2 times 2x plus 1 equals 3 times x plus 2. Are you going to have to distribute? Yes. So you are going to have to get rid of these parentheses. So that's why I mean that you're going to have to multiply the 2 by everything inside the parentheses. 2 times 2x is 4x. 2 times 1 is 2. Equals, again, you're going to have to multiply the 3. 3 times x is 3x. 3 times 2 is 6. Remember, everything is multiplied by that number outside. Now we go and solve. I'm going to subtract 2 from both sides. Again, there are other ways to solve, but this is just the way that I'm doing it now. 6 minus 2 is positive 4. Minus 3x minus 3x. 4 minus 3x is x. You could put the 1, that's fine. You could put the 1 right here, equals 4. So that's my answer, x equals 4. So if I put the 4 back in for the x here, and I put the 4 back in for the x here, the equation's going to work out. It's going to check out. So I found what that missing number was, which is 4. Okay, that's solving. Now, let's take a look at some exponential functions. We're going to be finding the y-intercept, finding an asymptote, what an asymptote is. It's fun to say, it's fun to write. So let's look at the function y equals 2 raised to the x power plus 3. So the reason why this is called an exponential is because x is in the exponent spot. Exponent spot. That's why it's an exponential function. Okay, first, find the y-intercept. When we find the y-intercept, what we have to remember is that x is 0, and we are looking for the y. If you can remember that, you can find your y-intercepts. If you can remember that when we find the y-intercept, x is 0. So what does that mean? Well, we put 0 in for x. So y equals 2 raised to the 0 plus 3. Anything to the 0 power is going to be 1. So 1 plus 3. So y equals 4. So our y-intercept is 0, 4. This is your answer. You write it in point form. Okay. Next, the equation of the asymptote. I actually want to graph this to show you what the asymptote is. So I'm going to turn my calculator on. Clear this, clear that. Okay, y equals 2. Remember, the exponents button is right above the division symbol. It is right here. Raised to the, here's your x. Get out of the exponent spot, plus 3. And I'm going to press zoom, and then I'm going to go standard just to see what the standard looks like. Pretty cool. Okay, so what do I mean by asymptote? Asymptote is an imaginary line such that this blue curve here will never cross the imaginary line. And so this imaginary line is actually approaching, and I'm going to bring it up. I'm counting by 1. I press zoom standard, which means that I have counting by 1. So 1, 2, 3. So if you look at this y-axis and you look at the number 3 right here, our blue curve will never go below 3, ever. It's a sad story, and that's what an asymptote is. It's the number that the curve will never go below or above. So our equation of our asymptote here It's going to be y equals 3. How did I know that? Well, if you look at this number here, the number that's being added on is going to be your asymptote. That's it. That's where you find it. Okay, so asymptote is the imaginary line that the curve will never cross. It'll try to get there. It won't cross, which is the sad story. Okay, state the domain and range of the function. Well, first, let's start with the domain. Remember, the domain, we're looking at our x values, and our range, we're looking at our y values. So here we have the x-axis right here. There we go. Here we have the x-axis. So if we look, the curve is going towards all the positive x, and the curve is going towards all the negative x. And if we go towards all the positive and all the negatives, you're right. X is all real numbers. Okay. Now for the domain. Remember that asymptote that we were talking about? Well, now for the range. I'm going a little fast. Let me slow down. Now for the range. So we're going to look at the y values here. And remember that imaginary line that our asymptote will never, or our curve will never cross? Well, it can go towards all the positive y values. So you see it is going up, going towards all the positive y values. However, it is never going to go below 3. It will never go below 3. So that means our range, our y values, are always going to be greater than 3 because it's never going to go past that imaginary curve. It's always going to stay above 3. Okay, sketch the graph of the function showing the asymptote as a dotted line. So we can do that. I'm going to put 1, 2, 3, 4, 1, negative 1, 1, here's x, here's y. So remember, it's never, let's put our dotted line here. So at 3, we're going to put a dotted line. And then we're just simply going to draw the curve in. The y-intercept was at 4, remember? We got that up here. The y-intercept was at 4. So here's 4, so it goes through 4, and then it goes all the way up. So here's our little drawing. Y-intercept's at 4, we found that. Imaginary line, we found that, will never cross, and there's our curve, and that's how you sketch it. Okay, using your GDC, solve the equation. So remember we were talking about same bases? Well, it's difficult here because we have 2 and we have the base of 3. So it's going to be very hard to get this as same bases. So what we need to do is use our graphing calculator to solve this, which I believe is going to be the easiest way for us right now. So what we want to find out is we want to find what x value we can put in where these two are equal. So we want to find where they cross. Find the intersect point. And this is where they cross. So what we're going to do is first in y1, we're going to put 2x plus 3. And then in y2, so this is going to be our y1, and this is going to be our y2. Our y2 is going to be 2 plus 3 to the negative x. So let's put that in our calculator. On y equals, we already have 2 to the x plus 3. Now let's do 2 plus 3. Be careful because you're going to use this negative button down here for that exponent. Negative, 2 plus 3 raised to the negative x. So make sure that it's in the exponent spot. Don't make my mistake. Now let's press graph and see what this looks like. We should get a red curve in there. There we go. So we have a blue curve and a red curve. So we need to find where they match, where they intersect right here. And you're right, we are going to be using our second trace. So we're going to press second, and then we're going to press trace, which is right here. And yes, we are going to use number 5, which is intersect. So press number 5. Now, it's going to ask you down here, first curve. So it wants to know which one do you want me to go to first. And it landed on the blue, which is fine. So when it says first curve, make sure it's on 1, and then just press enter. And then you can see that it jumps to the next curve down here. It jumps to the red one. I just kind of moved it over so you can see the blinking dot. And so then it asks you, is this the second one you want me to look at, because sometimes we can have multiple curves. We can have 5 or 6 curves on here. So we only have 2, which I'm just going to hold you to 2. So it's asked second curve. So yes, it's on the second one. So you're just going to press enter. Then it says, do you want me to take a guess? And you're going to say yes, please. So again, you're going to press enter. And it gives you on the bottom is your intersection. And so your intersection's negative 0.4895, comma, 3.71. So remember, we're looking for the x value. So how we're going to solve this is you're going to say, okay, x equals negative 0.4895. Can you round that? Yes, if you wanted to round to negative 0.490, that would be 3 significant figures, and that's what Ivy does like, is 3 significant figures, or 3 sig figs. There's the lights. Sorry, everybody. So that's how you solve it. So please make sure you write down all of these notes. If you tend to forget how to do it, they're all right here. We're looking for our x, and that's how you find where they intersect, and that's how you solve for x. Okay, and the last thing is going to be problem solving. So we started with solving equations, and then we looked at graphs of the equations, and now we are going to be using all of those skills and concepts to solve problems. And that's why we learn math. So here we have the value of a boat in Y in thousands of UK pounds, pretty cool, they're in the UK now, is modeled by the function Y equals 20 times the quantity 8.85 raised to the x power, where x is the number of years since the boat was manufactured, or built, if you want to say. Now, is this an exponential function? Yes, because the x is in the exponent spot. Now, I'm going to ask you, please, actually, I'm going to require you, please, on your paper, I want you to, pretty please, where you see the Y, put a little arrow, and then write what it is. It's thousands, it's the cost in thousands of pounds, but I'm just going to label it cost. Then, yes, I'm going to want you to put a little arrow to where the X is, and I want you to tell me that's the number of years since manufactured. And let's put number of years since it was made. You can put made, you can put built, doesn't matter, but please label your X and Y. It makes for doing the problem so much easier. Okay, part A, find the value of the boat. So what are they asking for? The value. Which one is that? That's going to be Y. So we're going to find the value. We're going to find the cost value. Let's even label it other words that the problem uses so that it, again, makes it easier. So find the value of the boat when it was brand new. What does that mean? When it's brand new, how many years since it's manufactured? If it just came out, you're right. So X is going to be 0. I'm actually looking for the Y-intercept here. That's what I'm actually looking for. It's asking us to find Y when X is 0. Yay. All right, so what are we going to do? Y equals 20 times 0.85 raised to the 0 power. You can put this in the calculator as is. If you aren't going to put it in the calculator, what you do is you first do the exponent. Do the 0.85 raised to the 0. Anything to the 0 power is 1. So Y equals 20 times 1, which is 20. So the value of the boat, 20 and now 1,000 pounds. I believe the L, I believe it's like that, the symbol. Correct me if I'm wrong, please. That's a symbol for pounds. Okay, part B. Estimate the value of the boat. Okay, estimate the value of the boat. So we're looking for Y. When it is 3 years old. What's years old? Years old. So X equals 3. Give your answer to the nearest pound. Again, substituting it in, absolutely right. Y equals 20 times 0.85. They gave us a value to substitute in. So when you see that they give you a value, you just have to make sure, is it my X or my Y that I'm looking for? But it said estimate the value, so we're looking for y. So y equals, again, you could just put this in your calculator. 20, don't forget your parentheses, 0.85 raised to the third power. There we go, 12.2825. So let's write that down, 12.2825. And it said nearest pound, so that's going to be nearest whole number. So it's going to be about 12,000 pounds. You could write the zeros if you want. In the problem, they wrote thousands, so that I'm just using what they wrote in the problem. If you want to write 12,000, you can. Either way works. Don't forget the pounds. And lastly, use your graphical display calculator to estimate when the value of the boat will be worth half of its original value. So first, what is the original value? Well, we found that in Part A. Part A, the original value was 20,000 pounds, so 20. Okay, so what's half of that? Half of that is going to be 10. I just did 20 divided by 2. That's all. Okay, so we want to know when it equals 10. So we want to know when this equation, yes, I'm setting you up right now, is going to be equal to 10. So we want to know when 10 equals 20 times 0.85x. That feels familiar where I have a y1. Actually, let me rewrite it the other way because you know me. Okay, where the 20 times 0.85x equals 10, where y1 equals y2. Now, you could go through and solve this. There is another way to solve this. I am going to teach you that way. But here's the thing. The first way that we learned how to solve it in the beginning of this video, you can't change the same base. The 0.85, I'm not going to get there. So I haven't taught you the second way of solving, so we have to use our graphing calculator, and that's why I'm setting it up like this, and that's why I reviewed what I did before, and I taught you what I did before. So we want to know when this side is equal to half its value, which is 10. So set them up, y1 and y2. So let's go back to our graphing calculator and clear these out. Okay, so you ought to know when 20 times 0.85 raised to the x is equal to half its value, which is 10. Let's see what that looks like on a standard graph. We might not be able to see it because, well, there you go. We're just on it like right up here. Wow. So what I'm going to have you do, because I want to see this, and I haven't taught you this before, but if you use these right and left buttons, the blinking dot comes up. If you go around where you want to find the graph, so I want to investigate this point, and I press zoom, and I'm going to press 3 for zoom out. I'm zooming out. What it will do is it'll move my calculator picture over so that I'm able to see that. There we go. So I want to get that intersection point. So you're right, we have to go back. I want to get where they intersect, and we're going to do these, because I want to see when these are equal, and where they're equal is that at this little intersection point right here. But I can't move my little button because it doesn't get it exact. So that's why we have to press second trace. We want to do number 5 for intersect. First curve, make sure it's on one of them. It usually chooses the Y1 first, and you're going to press enter. And then it should do the second curve, yes. So we want the red one, and the blinking dot is on the red one, so yes. You want me to take a guess? Yes, please do. And the intersection is at x equals 4.265 and 10. So that's what we were looking for. We were looking for when y is 10. Remember, we want to know when it's equal to 10. So what's that x value? The x value is 0.4265. What does that mean? Well, let's go back. Estimate when the value of the boat will be worth half its original value. So we're looking for x. And if you're like, oh my gosh, what's x again? Let's go up here. The number of years. So it will take... Oops, it will take about, and you can round, 4.3 years to reach half its value. So what this is it's depreciating. So over time, when you buy a boat, a car, a motorcycle, over time it's going to lose value because you're using it. So it starts off at 20,000 pounds. That's what you bought it for. But then after about 4.3 years, it's going to just be worth half that value because you're using it. You're putting use into it. So it's depreciating. So when you look at this calculator, see this blue curve? This is called decay. So when your curve is going down, it's decaying. So let's just go over this two quick pieces. So this is called exponential decay. I might ask you that. I might say, is this exponential decay or exponential growth? So when you grow exponentially, you're increasing. So this is exponential growth. So if I ask you, is this function growth or decay? Graph it and see, is it going down? If you look at the graph from left to right, is it decreasing? Or if you look at the graph from left to right, is it increasing? And that's how you know it's exponential growth or decay. This has been exponential equations, solving, looking at their graphs, exponential functions, doing a little problem solving. I hope it helped, and I will talk to you soon. Thank you.